Ya, assalamualaikum warahmatullahi wabarakatuh. Kembali lagi sama saya, AldianRidho Kusuma di sini ya. Nah, akan buat video. Maju kursi Steganografi. Gunakan apa nih? HXD. Cenah. Hapus dulu, kita hapus. Nah, yuk kita buka. Foto yang mana ya? Foto mengoleh aja. Nah, ya fotonya mengoleh. Cenah. Ke dulu. Record. Nah, kita cari HXD tutorial using kita tonton.
Now, the first thing that we do is we need to get into the vSphere Access server here, and that's going to give us a Windows 7 desktop. Now, once we're in the Windows 7 desktop, then we can get our hexadecimal editor working so that we can actually be able to open up images and be able to look at the hexadecimal values that are really just the representations in hexadecimal numbers of the bytes that we see in the image. So the first thing I want to do is I'm going to go to my S drive here, and I'm going to look for CFDI 320, and I need to install HXD, which is my hex editor. So I'm going to accept this, and this has got to be done every time because at the moment this program isn't installed on the system, and so you've got to install it. It takes just a second, though. You can see how fast that actually is. And then we're going to launch this. So there are some challenges with using a hexadecimal editor with image files. And let me explain that to you here. So I'm going to go to Computer, and then we're going to go to S, and then back to CFDI 320. And I'm just going to grab this disk image here. So the reason I say that it's challenging a little bit is because PC-based systems, ones with an Intel processor, actually use a different way of writing numbers than what you are probably used to. I would expect that you are used to anyway. So when I write a number like this, what you're thinking at this point is 1,234. Now, that's what we call big endian because we're writing the big number first. That's the 1,000, followed by the 200, followed by the 30, followed by the 4. We go from big to little, and since we write left to right, we are writing the big value first. If I were to do this instead and still maintain that that's 1,234, that would be written in little endian format. Because what we're doing is we're taking the ones place here, and we're writing it first. That's the littlest value. And then we follow that with the 30, and then the 200, and then the 1,000. So that's little endian versus big endian. Now, PCs or Intel-based systems use little endian, and that can be challenging because what you need to do is you actually need to reverse the bytes. So let's say we wanted to convert this particular value here. You can see it's 33C0. However, what that actually is C033. So let me bring up our calculator here, and we can just do a little conversion. And I need to change this over to programmer. And we're going to be using hexadecimal values because that's what these are. Hexadecimal is a base 16 number system, so we count from 0 to F. You can see we go A, B, C, D, E, F, and we do that starting after 9. So there's a total of 0 to 15 is our number-based system. So just as we're used to decimal, which is a base 10 number, we go from 0 to 9. With hexadecimal, we're going from 0 to 15, total of 16 values. So if I want to convert 33C0, what I need to do is plug in C033. Because with little endian, I'm writing the smallest value first, but that's not the way our calculator here is designed to operate. It's designed to operate with the big value first, followed by the small value. Now, we are doing the reverse when we are going from byte to byte. Inside the byte itself, there's no reverse because this has already been converted for us. So with multi-byte values, we reverse the bytes. We don't reverse any of the values inside the bytes. So this would not be 0C, for example. It is C033. Now, in order to convert that to something that we can actually understand, I hit des and it converts it to a decimal number for me. So I've got my decimal number 49,203. C033 is 49,203. If I've got a 4-byte value, for example, these 4 bytes here, this would become D08EC033. Remember, the little value is first, so in order to convert this and read it correctly, what we have to be doing is converting this by reversing the bytes. Remember, we're reversing the bytes, not the byte values. So we're doing D08EC033. So that's just a couple of tricks that you can use as you are looking through your disk images in order to convert values. So the other thing to keep in mind here, this is pretty straightforward, but let me just walk through this quickly. So this is the offset here in the left. So we go from 0 to F here in the first row. So that's 16 values rather. So 0 to F. This next row goes from 10 to 1F, 20 to 2F, and so on. So if we're looking for offset 16, that's going to be here. If we are looking for a forward byte value starting at offset 16, that's going to be these 4 bytes right there. And again, that value is going to be 1C6850A4, because remember, we are reversing the bytes in our 4-byte value. So the offset here on the left, and then the columns are going to give you the specific byte number. So we've got 0, 10, 20, 30, 40, but inside each column, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So that's how you would interpret values in a hex editor with whatever type of input data that you've got. In this case, what we're looking at happens to be a disk image. Now, the first thing that we do...
Oke, kurang lebihnya seperti itu. Ya, kurang lebihnya seperti itu. Apabila ada yang tidak jelas bisa ditanyakannya. Kurang lebihnya mohon maaf. Wassalamualaikum warahmatullahi wabarakatuh. Itu untuk part 1. Kita lanjut aja langsung ke part 2 kali ya. Tapi bentar, kita ada yang WA. Kita coba ke part 2. Kita lihat soalnya. Lakukan pengajuan pesan pada citra yang menggunakan pesan yang disisipkan pada soal nomor 1 dengan melakukan penggantian semua bit LSB citra menjadi 0. LSB citra, coba kita jelajah apa yang diganti 0. LSB citra, nggak tahu anjir. Coba kita ganti 0 misalnya. Oh jadi kayak gini udah di ngolehnya. Coba kita ya, kita ganti 00 dimana ya, kita ganti 00. Save. copy, paste, nanti kita bandingkan. Oke, kita hancurkan lagi pesan ini. Jadi 01, semoga benar aku suka nih. Kayaknya udah cukup, kita save. Jadi gimana? Wah, mengolehnya jadi begini. Kita lihat. Nah, ini mengoleh yang udah dituin. Kita cari yang ini, open. Nah, bedanya nih, ini yang belum kita, yang udah buat kita dikit, ini udah kita downloadin semua jadinya begini. Oke, ya seperti itulah ya. Oh, seperti itu. Oke, kurang lebihnya mohon maaf. Wassalamualaikum warahmatullahi wabarakatuh.